Okay, here's the last two problems from the review packet, numbers 25 and 26. We're doing Pythagorean's theorem. Remember, Pythagorean's theorem is leg squared plus the leg squared equals the hypotenuse squared. We shorten that up by saying a squared plus b squared equals c squared. So in number 25, we have a right triangle, because it says that in the directions. Our legs are A and B. Our hypotenuse is C. Hypotenuse is always directly across from the right angle. Okay, so our hypotenuse is what's important that you place correctly. A and B are interchangeable. So in this problem, we see A is 32, B is 60, and C is what we're looking for. So we take our formula and we do 32 squared plus 60 squared equals C squared. So I get out my calculator and I do 32 squared and I get 1024. I do 60 squared, 3600 equals C squared. I add those two together and I get 4624 equals C squared. I'm going to square root the both sides to get rid of that square. Remember, when we square root both sides, we get a plus minus. Now this is a big number, so I'm first going to see, is it a perfect square? So I'm going to go second x squared, so I have a square root, and go 4624 and enter. And this happens to be a perfect square, so I don't have to do any prime factoring here. Now I do get an answer plus minus 68 equals C, but only one of these are true. One of them is extraneous, and the reason is we're talking about the side of a triangle. If we're talking about the side of a triangle, we're talking about a length. If we're talking about a length, it has to be positive. So the only answer here is 68. Negative 68 makes no sense in terms of this problem. Algebraically, it's correct, but geometrically, it is not. Okay, number 26. Again, it looks a little bit backwards. So I'm going to just draw it the way it's shown. And then I'm going to put my A, B, and C where I believe they are. Remember, C is always across from the right angle. It's also always the longest side. In this case, we don't know A. We know B is 11, and we know C is 19. So let's fill in what we know. It's going to be A squared plus B squared. That's an extra little dot there. I don't want anybody to think that's a negative. Equals 19 squared. So I have A squared equals, or plus 121, and then 19 squared is 361. Now I actually have to solve this equation. So I'm going to subtract 121 from both sides, and I'm going to get A squared equals 240. I'm going to check. Oh, I'm going to square root both sides, sorry. And again, that's going to give me a plus minus here. Always when you square root something, you're going to get a plus minus in front of it. I'm going to check and hope that the square root of 240 is perfect. Whoops, square root of 240 is not perfect. I get a decimal. So that means I'm going to have to prime factor because I don't want decimal answers here. So this is going to be 2 times 2 times 2 times 3 times 2 times 5. Now you might want to go off to the side and do the factor tree. I did it in my head, and now I'm checking it on my calculator to make sure I did it correctly. And now I'm going to look for my pairs. I have two sets of 2, another set of 2's, and that's it. Left behind, we have a 3 and a 5. So what comes out is we have a plus minus 2 times 2. Left behind is 3 times 5. So our final algebraic answer is plus or minus 4 root 15. But we just discussed that if we're talking about the length of the side of a triangle, that's not going to be negative. So geometrically speaking, the answer is A equals 4 root 15. And that's going to be our answer.